Hey, this is Joe, and today we're going to talk about completing the square for a quadratic expression. Moreover, we're going to talk about how to complete the square when a is equal to 1. In other words, we're going to have no coefficient in front of our x squared term. And we complete the square when we're trying to get our standard form quadratic into the vertex form quadratic, or we complete the square in order to find the x-intercepts a different way, other than using the quadratic formula or factoring a quadratic. So let's talk about the process of completing the square. So here I have my quadratic in standard form. And the first step we're going to do is we're going to essentially add a form of 0. In other words, if I were to add 0 to this quadratic expression, I would have the exact same thing. And another way of adding 0 is adding and subtracting a particular value. In this case, we're going to add and subtract b over 2 squared. And the reason we add and subtract b over 2 squared is because this value completes the square of the expression that's within the box here. In other words, we can replace with the expression in the box with the quantity x plus b over 2 squared. And leaving everything general as I've done here is kind of confusing, so let's talk about a particular example. Let's say we want to complete the square of x squared plus 8x minus 5. Here, our b value is positive 8. And so b over 2 squared, which is 8 over 2 squared, is the same thing as 4 squared, which is 16. And so we're going to add and subtract 16 to our quadratic expression. And we're going to add the 16 right after the 8x here. It just so happens that x squared plus 8x plus 16 is the same thing as the quantity of x plus 4 squared. And this is the reason we pick 16. In other words, these three terms are going to factor to x plus 4 squared. And we can check that this is true by simply FOILing out x plus 4 squared. In other words, that's x plus 4 times x plus 4. That gives us x squared plus 4x plus 4x plus 16. And that gives us x squared plus 8x plus 16. So our next step is simply replacing x squared plus 8x plus 16 with x plus 4 squared. And that gives us x plus 4 squared minus 16 minus 5. Next we would just combine minus 16 minus 5 and we get negative 21. And so our result is x plus 4 squared minus 21. And the reason we add and subtract the b over 2 squared term is so that we can complete the square with the x squared plus 8x terms here. And so if we look back at that process I was talking about earlier, we can always check that the result we get from this process is correct by simply FOILing out our result and making sure that we get the appropriate quadratic that we started with whenever we combine all of our like terms. So why don't we work through another example? In this case, let's work with a b value that's negative instead of a positive b. In other words, let's consider the expression x squared minus 4x minus 5. Here, b is negative 4, and so b over 2 squared is going to be negative 4 over 2 squared, which is negative 2 squared, which is positive 4. And so we're going to add and subtract positive 4. This gives us x squared minus 4x plus 4 minus 4 minus 5. And the three first terms, the x squared minus 4x plus 4, will factor to a perfect square. In this case, that is x minus 2 squared. And notice that the second term within this binomial is always going to be your b over 2 value. So our b value is negative 4, so b over 2 is negative 2. And if we did this all correct, you should put that in this position. And finally, we would combine our constants. In this case, we'd end up getting the quantity x minus 2 squared minus 9. And so we're done with the process. I'm Joe, and thanks for spending some time with me.